So the funny thing is that I just recorded a couple, not minutes, that would be an exaggeration, a little bit with me talking and hadn't pressed the record button. I've never done this before with my, so the video you're watching today, you're going to see bits recorded on 4 different devices, all spliced in together if I can pull it off. Anyway, what I wanted to do for you, and I'm hoping that a bunch of you will be able to skip over this part, but I want to point out that the AP calculus classes at this point have to use a graphing calculator for the AP exam. And so I don't want the AP exam to be the first time that you're using the graphing calculator instead of Desmos. And so I would strongly encourage you to get very familiar with how the graphing calculator does some of the things that we're doing. Although I agree, I hope you do too, that Desmos is better at most of this. I want you to also have a familiarity with the graphing calculator. So having said all of that, what I what I want to do is show you this example number 3 on the graphing calculator, and how we set up the table. So let me go to the y equals screen, and I'm going to press alpha y equals and enter to give myself that fraction. And then the equation itself in the numerator is x squared minus 4, and you want to type it in exactly as the equation appears. Don't cancel anything, because that's where you're going to generate the whole. If you were to cancel it before you type it in, it doesn't graph the rational function, it graphs the simplified function. In this case, it would be just a straight line. I'm going to down arrow to the denominator, and then I am going to type x minus 2 and here in the middle you'll see that there's the graph of the function, and you'll see a table of values. And if you wanted to look at the table of values, now that's in my screen, but if you wanted to look at the table of values in your calculator, you could do second and then graph, and that would give you that same table of values that you're seeing in the middle of my screen. And the problem is that all you get are x values that are whole numbers. And of course, this would help you to graph this function. And so you could just, if your graph space goes to -10 and +10, you would just go to when you see x is -10, and you would graph all those points. And as you need to scroll, you can scroll until you see that you've got x is +10. Also notice that x equals 2, it says error, but that just means that there's a hole at x equals 2. And we can talk about that point in just a minute. So moving on then, what we want to do though when we're talking about limits is I'm asking you in this example to look at the limit as x approaches +2. Well, x equals 1 and x equals 3 are not mathematically close to x equals 2. $1, $2, and $3 are mathematically close to each other, but when we're talking about limits, we want hundredths, thousandths, 10,000ths, lots and lots of decimal places close to a number. And so you want to change the x values that feed this table to match the numbers that are, in this one example, the numbers that are in the table already given to you. So what I'm going to do here is I'm going to go to, see how it says table set in blue right above the window button? And I don't know if you can see my mouse in this video. I'll find out too late. So anyway, I'm going to press second and then window, and that gives me this table set menu. And if you change the thing that says table start, it'll just change the x value at the top of the screen, so that if it says 0 there, it's going to start your table at x equals 0 and go from there. And you could make that value -3, and then look at the table, and the table will start at -3. I think my clock is going to go off because, it's got to do that. If you look at delta table, this little triangle is the Greek letter delta. If you look at delta table, what that tells you is the interval. So if I start at -3, I'm counting up by ones. If I wanted to start at -3 and count up by threes, I would just change that number to 3, and then my table would go -3, 0, 3, 6, 9, 12, and so on. I don't necessarily know how useful all of those options would be, and so I'm going to change this back to 0 because it doesn't matter, and I'm going to change this to 1 because it doesn't matter, because in a minute those two choices are going to go away. What I want to do is remember that if I want to control the x values, x is the independent variable. And right now, your calculator defaults to automatically choosing your independent and thus your dependent variables. And so what I'm going to do here is I'm going to go down arrow to independent, and I'm going to change auto to ask, meaning it's going to let you choose the independent variable. And so I'm going to hit right arrow so that the cursor is blinking on top of ask, and then I'm going to press enter so that now ask is highlighted. And if you look at your table, the table is going to be empty. But notice that at the bottom of your screen it says x equals. And so what I'm going to start doing is typing the numbers that I want in my table, in the x values of my table. So I'm going to start with my 1.9, and then either enter or down arrow. And it tells me that where x is 1.9, y is 3.9. Then I'm going to enter 1.99, and then I'm going to enter 1.999. And then remember that we're skipping the 2. And now I'm going to enter 2.001, down arrow, 2.01, down arrow, and 2.1, down arrow. So this is how you enter the tables that we're going to be using for limits using the graphing calculator instead of Desmos. And in the notes I wrote, press second table set. That's how you get to the table settings. And then a note that you want to change your independent input from auto to ask. And then when you go to second table, you can enter whatever numbers you want into the x values.